Algebra 1 students,
Let's get it started.
welcome to your first video notes of the year. This is Mr. Hale, and I think it's time that we get it started. Let's get this thing rolling. So today we're going to actually look at two different sections, 1.3 and 1.5. They deal with a couple topics: real numbers, the number line, and then addition and subtraction. So it's a lot in one day, but it's pretty straightforward stuff for the most part. It especially helps if you know your multiplication tables. That's very helpful here. So let's get started on this. Let's take a look. If a squared is equal to b, then a is the square root of b. So in other words, a number times itself equals another number. That's called a square root. And I think you guys have seen that before. So here's the idea. To simplify, we have what are called perfect squares here. The square root of 4, that's just saying what number times itself equals 4. That's, of course, 2. For number 2, the square root of 64, again, what number times itself equals 64? And we all know that that's 8 times 8, so 8 is the square root of 64. All right, on number 3, this one's a little different because we have the fraction. So we're going to actually treat it as two separate problems. One of them being the numerator, square root of 81. The other, the denominator, square root of 49. We're going to, again, treat these as two separate problems. We know the square root of 81 is 9, and we know the square root of 49 is 7. So 9/7 is your answer. All right, next topic, it's somewhat related, but this time we're going to approximate square roots by basically choosing the integers that it's closest to. So here's what I know. Square root of 73 is not an exact integer value. Instead, what we've got here is something that's between two integers. And as a matter of fact, when I think about it, the perfect squares that I know are close to 73, the one below that would be 64, the one just above that would be 81. This one is 8 squared, 81 would be 9 squared. So what I'm looking for is the two integers closest to the given square root. We would just simply write 8 and 9. In other words, I'm figuring out where square root of 73 falls between. I just want to get an approximate idea. Okay, so number 5, the square root of 19. I know that 4 squared is equal to 16, and I know that 5 squared is equal to 25. So I know it has to be between those two, so I would just simply say it's between 4 and 5. And I didn't really need to write the word between, but I did. So there it is. All right, why don't you guys do this? Pause the video, do number 6 on your own. Once you've done it, hit play again, and then see how our answers compare. All right, welcome back, folks. You can see my work on number 6. Square root of 119 falls between 10 and 11. Essentially, I knew 10 squared was 100, 11 squared was 121. You guys all learned those facts in 3rd or 4th grade, so you still know them well. And, of course, 119 is between those two numbers, so it's somewhere between 10 and 11, probably a little closer to 11, but we're not going to get too worried about that. All right, let's take a look at number sets now. This is basically a way of classifying things. You can see we have two big groups. Well, one big group of real numbers, all of them are real. But then we have a big group called rational numbers, which is everything on the left rectangle that you see here. And irrational numbers are over on the right. You can see examples of each. Irrational numbers are often like square roots that can't simplify to integers, or numbers like pi. Or any other decimal that's not repeating and non-terminating. So in other words, it goes forever. And there are a few more math constants you run into later on in your mathematical careers that you may see are irrational numbers. But the most common one you'll see would be square roots and pi. Rational numbers is essentially a group that we could turn into fractions. So some of them start as fractions, like the example you see there is negative 2/3. But others are, decimals like 0.7, or this one's 0.3 repeating, which would be exactly 1/3. Okay, integers is what we think of as like numbers that don't have a fraction or a decimal involved with them, although they've kind of thrown you off a little bit on the two of the examples you see here. Remember, 10/5 is actually 2, and square root of 16 is actually 4. Now they've included both of these as negatives, but integers would also include numbers like 0 and 7 and 5 and 2 all these sets that are inside here are also included in integers, and they're also all included in rational numbers. Whole numbers only adds one number to the set as we move that way. That's the number 0. And then natural numbers includes all of your counting numbers. The ones that you learned before you were even in kindergarten are your natural numbers. All right, so name the subsets of numbers to which each number belongs. On number 7, I see that I have the number -8. The first thing I know is, okay, it can't be natural and it can't be whole because it's negative. So essentially what we have here is we know that -8 is an integer. It doesn't have a fraction or a decimal value to it. And then we also know that it's a rational number. And that's it. That's -8. Okay, the number 75 is in a little bit more because 75 would be all the way in this deepest group here, natural numbers. So we know that 75 is natural, and if it's natural, it's got to be a whole number. It's also got to be an integer, and it's rational. Okay, on number 9, square root of 18. Now we've seen numbers like this on the previous slide, but square root of 18 is not a perfect square. It's somewhere between 4 and 5. Now we're not using calculators, remember, but if we did punch that in, you would get 4 point, and then there'd be some weird decimals after that. This is not natural, not whole, it's not an integer, it's not even rational, because you can't turn square root of 18 into a nice pretty fraction. So really the answer here is it's irrational. Those are our irrational numbers. Okay, again, why don't you pause the video, do number 10 on your own, and see how our answer. All right, you can see my work on number 10 now, and basically it's rational, and that's it. It's this group right here. 5/8 would fall into the same group as like -2/3. Okay, and it doesn't fit any of these others because it's not an integer, and if it's not an integer, it can't be a whole or a natural number. All right, continuing on, we're going to do some ordering. So here's the way I want to do this. I want to find the smallest numbers first. So of course when we look for smallest numbers, we're looking for negatives. So I'm going to look at those two first. I know -3 is the smaller of those two, and then -2.8 would be next. Okay, so now I'm looking at the positive numbers. I'm going to have to do a little bit of approximation here. Okay, so we got 4. 11/3, that's like 3 2/3. Square root of 17 is 4 point something. Okay, we don't know what, but we know it's a little more than 4. And that should help us be able to organize these. So I see of the 3 that remain, the smallest of those would be 11/3. Next would be 4, and then the last one would be square root of 17. So we've organized that from the smallest number, -3, up to the largest, which is square root of 17. All right, on number 11, it's the same instructions, and again, we're going to have to do just a bit of approximation to kind of figure out exactly where these numbers fall. And one thing I notice is 4 of the 5 are negative. So I know right at the end, 0 is the largest number in this list. So let's go ahead, and the ones that aren't integers or nice decimals, let's go ahead and put some approximations there. -11/2 we could do as -5.5 or -5.5 if you want the fraction. Square root of 21 is -4 point something. We don't know exactly what, but we know it's between 4 and 5 on the negative side of things. And I think we have enough information. So I'm looking for the smallest number. -5.8 would be the smallest of these. Then we'd have -11/2, and then -5. Then our negative square root of 21. And then finally, the largest of this list would be the number 0. Continuing on, we're going to do a little work, continuing to practice our order of operations. We run into some new things here today, nothing crazy. But remember, when you follow the order of operations, you got to do 3 plus 2 first. So we'd have 4 squared minus 5 squared. Then we'd apply our exponents, so 16 minus 25. And finally, we'd get -9 is the answer. We're finding the difference between 16 and 25. It's 9, but we're subtracting the larger number. We'll talk more about the whole adding and subtracting negatives in the next slide here. All right, on number 13, why don't you pause the video, do it on your own, and then compare your answer to mine. You did pause that video, right? Okay, good. So here we go, number 13. I got -2, and you can see how I did it. One of the big things to remember is that this big fraction bar here represents a grouping symbol, so you have to treat the numerator and denominator separately. So I went through, I dealt with the exponents, and I went ahead and did 8 times 7 on the same step, even though technically those are separate steps. And I dealt with the denominator separately. 2 times 5 is 10, and it all worked out nicely to -2. All right, last thing we're going to look at today is evaluating, and we can use a number line. Some of you won't necessarily need it, but I'm going to show you the idea. So on number 14, we've got -5 plus 8. So what I'm looking at here is -5 is right there. If I were to count forward 8 spaces, there's 1, 2, 3, 4, 5, 6, 7, 8. We'd find our answer right there, 3. All right, now again, some of you are probably thinking, that's pretty silly, Mr. Hale. I'm pretty sure I can handle doing -5 plus 8 without having to use a number line. And if that's you, that's spectacular. You go for that. All right, no pressure from me. All right, here's your next one, 4. So again, we're going to start up here at 4. And this says plus a -7. If you add a negative, that's the same really as subtracting. So 1, 2, 3, 4, 5, 6, 7. Not sure what happened right there. All right, and we get our answer right there. It's -3. And once again, many of you are probably thinking, I don't really need the number line. Again, totally fine. All right, then number 16, -3 plus -2. This time, if you use the number line, you're going to start out here at -3, and we'd have to go left 2 more spaces, so we would get -5. All right, and our last problem today, number 17, -8/5 plus 4/5. This one's a little more challenging to use a number line because they're the fractional values. So what I would do is think about maybe if we just consider the numerators only, we already have a common denominator. So if we start at -8 and we add 4, 1, 2, 3, 4, we'd have our numerator, okay? Now the denominator would stay the same. It's 5. All right, folks, for some of you this will take a little work. For some of you this might be easy peasy, but in any case, you guys make sure you go ahead and get to work and have a spectacular day.